So we've used these limits of the Riemann sums to calculate the exact area and going from the Riemann sum to an integral. Now we could also use this same expression. So instead of letting n be infinite, we can just have a finite number of n's. That means we are adding up a finite number of rectangles. But we could still use the same expression to do that. So the this expression here is a previous example of our negative x squared plus 4. We replace the x with a k times 2 over n, where 2 over n is our dx, and then times that by our 2 over n on the outside, which is our dx as well. So using this expression, we can calculate these rectangles that I've drawn here. So first thing I'm going to do is I'm going to simplify this expression. So instead of using this expression, I'm just going to simplify this a little bit first. Okay, so here I'm going to use 4 rectangles. I'm not going to let n go to infinity. I'm just going to use 4 rectangles. So I'm going to end up with 2 over 4 simplifies to 1 over 2. So I end up with negative k squared over 4 plus 4 times 2 over 4 becomes 1/2. And so my simplified formula becomes negative k squared over 8 plus 2. Okay, so each rectangle is going to be based on that expression. And as I plug in my k values, when k equals 1, I'm going to get negative 1 over 8 plus 2. That expression gives me, that's going to give me 15 over 8 plus k equals 2. When k equals 2, I plug that in, I'm going to get 2 squared minus 8. So 2 squared over 8, is negative 4 over 8 plus 2. That's going to end up being 12 over 8. Plus, when k equals 3, I end up with negative 9 over 8 plus 2. That's going to end up being, that looks like it's going to be 7 over 8. And when k equals 4, I'm going to end up with negative 16 over 8 plus 2. That's going to be equal to 0. And you can see that that last rectangle has a height of 0. So when I put in those values, this rectangle is 15 over 8. Okay, so that's my value, 15 over 8. This is going to be 12 over 8. So this rectangle that I've drawn here, this rectangle is 7 over 8 area. And then the last rectangle you can see has no area. And so when we sum this all up, the rectangular area approximation is going to end up being 27 plus 7 is 34 over 8 units squared of area. So this we can use this Riemann sum expression, the sigma expression, and let n go to infinity to get an integral, or to go from sigma to integrals. But we can also just use the same expression, just plug in a finite number of n values, and we can actually calculate each rectangle separately using that expression.